So, hi everyone, am I audible? Please confirm by typing in the chat box. Great. So, let's start today's session. So, I'm Rupesh Kumar and I am taking this and problem solving through programming in C NPTEL tutorial sessions. Today's 2nd February 2026. It's Monday. So, let's start today's session. So the way this session will be held is like this. I will be communicating you via audio. I'll be showing some problems for this week, and I will solving those practice problems for you. And then you can ask queries based on those problems if you have any doubts related to the topics covered in this session, right? And the way you will be asking questions with me to me is via using the chat box. You always have to write your queries in the chat box. Do not raise your hands or do any other stuff, right? So just I think I won't be able to respond to hand raised queries. If you have any query, just type in the chat box. That's it, right? And yeah, and that's it. Yeah, fine. So at any instant, if you face difficulties such as the network is not accessible or any other issues, you can simply type in the chat box that my screen is not visible and I am not audible at that instant only, right? Do not wait for something. At any instant, if you have any doubts, just raise your hands. So just type in the chat box at any instant. If you have any query, just type in the chat box. Let's wait for a few more minutes so that everyone can join, and then we'll start the session. Also, this session is a recorded session, so all the doubts that I will be clearing in this session will be uploaded to YouTube, and you will be able to access the recorded session later on. Yeah, you will be able to look at the tutorial videos after the session also. So NPTEL team will be sharing these links to these recorded sessions. You can go to the course webpage and find out the links to these recorded sessions. There's a sheet that shares the document that I'll be using during this session, as well as the recorded, uh, as well as the recording. right? So yeah, so let's start the session, everyone. Hmm. Just a minute, guys. Let me set up my screen sharing. Yeah. Auto-operation 155. Next. So, hi everyone. Is my screen visible? Can you just confirm once? Is the text visible? Problem text visible? Should I increase the font size or tweak it a little bit, or is it fine? It's fine, right? Great. Okay. Okay. So let's start. Yeah. Hmm. So which of the following header files is not a standard C library? So first one is stdlib.h, second one is mat.h, third one is iostream.h, and fourth is stdio.h. So anyone, what's the answer? C, right? iostream.h. It it is not a standard C library, right? stdlib.h contains basic memory management functions, right? Math.h is for maths, for example, sqrt, pow, these kind of functions. Std is for input output operations, right? So the correct IO stream is not a standard C++ library. So option C is correct. Option C, right? Fine. Let's move on to the next question. What is the primary use of printer function in C? Anyone? What is the primary use of printer function in C? To read the input of from the user? No. To perform mathematical calculations? No. To display the output on the screen? Yes. So basically, printf is a statement that is used to display output on the screen, right? Now, to allocate dynamic memory? No. Right? So the correct answer is option C. Printf is used to display out on screen. How to use printf? So basically use usage. So the printf looks like this, printf, then string and pass your C string here, some C string. If you want to uh, print some numbers, so you can use string formatters in C. So basically some integer being printed, and then you pass the format specifier that I'm printing a decimal integer number, right? And then let's say I'm passing 10 here. So this is another way of using printf. And now let's say if you want to print some print two strings separated by a line, right? What you can say print printing line one, and then you can use these escape characters. The for backslash n is used for line change. So you can use escape character line change backslash n and then printing line two and then backslash n. What it will do? What will be the behavior here? It will what is the output of this? So I'm writing output in front of this. This will printing line one, and then it will leave a lines. It will change the line and then print the next line, printing line two. What it will do? It will print some. Let me write here. Some integer being printed, and that integer is 10. This will be printed on the screen. Right? And for the yeah, and then what will this print? This will print some C string, right? So this is how you can use printf in C. Anyone, do you have any doubts in this problem? Please raise your type in the chat box. Great. So let's move on to the next question. What is the purpose of return statement in C? Yeah. What is the purpose of return statement in C? So to terminate a loop, to end up. So everyone, are you familiar with these functions in C? I hope so. Have you seen function in C? Was are functions in C taught in the class lectures? Great. So basically, what are return statements? Return statements are used to exit a function and return a value, right? No. To end a program, no. To exit a function and return a value, right? Yes. To declare a variable, no. So what are the correct answer is answer option C, right? So basically, return statements are used with functions in C. Also, whenever you use a, let me write something here. Return statement is used with user-defined, basically, yeah, functions in C. It is used to tell that the function is exiting here and return a value from the function being called to the callee, right? For example, let's say I have a function. I hope you all know how to write functions in C. If not, we will be looking that also in later in this section. So let me just write this here. So let's say I have a function that returns an integer value. So I am my function looks like int. So this is a return type, right? Then I have a function name, some function. Let's say I'm writing a some function that takes the name of the function is sum. It takes two integer arguments, integer a and then integer b. I call these two integer arguments with variables a and b. And within the function body, I define the function, declare the function body using curly braces. And within the function body, I compute the sum of these two input variables. So I will say int c is equals to a plus b. So here I am using arithmetic operator plus. So that operates on two integer variables, operands a and b, right? And then what I do, I tell the compiler that I'm exiting this function here and I'm returning a value with this return of this function. So I'm returning C here. So now let's say let's say uh, this is my callee. What callee caller? What caller? Yeah, right. Ah, okay. So yeah, this is the caller. From the calling function call to the caller. Yeah, right. Right. So this is an example. This is my caller. So this function will be calling that function. So this is a callee function, right? This function will be called, and my caller function, what it does. So let's say I'm inside some function, right? And inside this function, I'm saying int x. So I'm declaring two variables, int x equals to 10. Then I'm declaring another variable int y to 20. And then I'm is creating a variable c that will store the value returned by the function sum, and I'm passing the arguments 10 and 20 to the function, right? So now my variable c contains the value that is the sum of the numbers 10 and 20. I can also check the value if the c contains the correct value by using the printf statement here that will print out the values. So I can simply say x plus y equals, and then I will pass the, fo- yeah. So basically I can pass format specifiers, percentage d, percentage d equals percentage d, right? And then I can say x, y, c, right? So this is how my function looks like. This is my caller function, right? So this is caller function. So now what I have done is I have a function sum with returns an integer value. It takes two integer inputs as parameters, int a and int b. What it does is computes. It uses binary operation plus on two operands a and b, and returns stores their sum, returns their sum into a third variable c, and then return the value c from this callee function to the caller. In the caller function, what I do, I define So hi everyone. Sorry, actually, what happened is there is some network issues on my end, so that's why you are not able to see my screen. So right now I am using my own network, so I hope it works this time. So let me resume the problem. Mhm. Is my screen visible, everyone? Great. So yeah. So let's now resume. I hope my screen is visible to everyone. Yeah. Right. So where were we? So we were seeing what is a function, how to write functions in C, and how to basically, yeah. So what is the return statement? Specifically, what is the return statement in C and what is its use case, right? Okay. Right. So let's start. So I hope now return statements are clear in C, right? Anyone, if you have any doubts, please write in the chat box right now, or we can proceed. Yeah. Right. So this PDF will be shared again. Don't worry. So now let's start question number 4, right? So what will be the output of the following program given below, right? So, right. Now, I hope you all are familiar with basic C++ C program, but let me give you a brief introduction to writing programs in C so that understanding what this program prints or does is clearer to you guys, right? So, Now, is my screen visible? So make sure I'm um, right. So I'm writing some contents here, right? So ensure that yeah. So how to write programs in C? So the first thing first is what are C programs? So for writing C programs, what you need is you need to create a .c file, a file with some file name .c. For example, in the screen you should be able to see this file hello world.c. The file name is hello world and it has an extension .c, right? So in any text file, if you write create this file hello world.c. So for example, if you are using Linux or Unix, you can simply use this VI editor or nano editor, in fact, right? Nano. And let me open up my file name, hello world.c. So in this file, I can write my C program, right? Write any C program, right? Right. So this is how you can uh, create C programs and yeah. So this was very basic of C, and now I'm going to in my text editor. You can use any text editor to write these program C programs, right? So for this purpose, I showed you one basic text editor that is available in most of the Unix and Linux distributions, which is Nano. Right now, I'm using an NVIM. You can also use it, but it totally depends on you, right? So let's write my first C program. Right. So the first thing that you need to define in your C programs is your if you are including any standard C libraries, right? So let's say in our program we are going to do some basics IO, right? Some basic IO. So I have zoomed in my to my screen. Yeah. So we are going to do some basic IO. So for that I'll be using the standard C library, uh, stdio.h. So what this library does, it contains functions for basic IO, right? Basic input output. Fine. So how it works, what it does, it's not something that we are interested in right now. Right now, we are interested in writing only simple C programs. So first thing first, you need to you need some boilerplate functions so that you can start writing C programs. And for that, you need to first include this function, right? Say this header, a hashtag include stdio.h, right? Now, for every C program, you have to write a main function. What is a main function? Main function is the driver code. What it does, it it runs the program, right? So whenever if you for a C compiler you pass a .c file, it will try to find the main function, and then from the main function it will compile everything else and create an executable binary. And when you run that binary file, then you will be you will be able to run your whatever you have written in your program, right? So let's define this main function. So for all functions, what is the how to declare C functions, right? C functions, how they look like. So first you have to type return type, right? Return type followed by function name, and then these small brackets. In the small brackets, you can pass arguments, right? Arguments, and the way is argument data type. So so data type of the argument, then the name. So for example, I have an integer argument, so integer arg1, right? And then I can pass multiple define multiple arguments for this for any function. So let's say I have a character argument here, so I can write char arg2 and so on, any combination of arguments, right? And which is totally optional. You don't need to definitely have some argument for a function, and then use these curly brackets to define the body of the function and body of the function, right? So inside this function body, you can write your function here. And at the end, if the function contains a return type, use return keyword, right? Else, otherwise not. Otherwise, uh, if the function contains a return type, just use return keyword. Otherwise, leave it as it is. Simply, it might be a function that only prints some values, right? Right. Now, what are the return types? Return type can be void. This means the function is not returning anything, right? Otherwise, it can be any primitive data type, for example, integer, string, integer, float, character, etc. Right? In future, you will see you can use other data types also, but how, that will be something that we will be looking into future. We are not interested into that right now, right? Right. So these are some basics of C functions, how to write C programs, and the main function is the most important function. And you must be wondering what are these double front slashes that I'm using in my program at the beginning of each line. So these are basically used to declare comments, right? So these are says double forward slashes are used to declare comments in C, right? So any statement that begins with double front slash will be ignored by the C compiler, right? So, hi everyone, just wait for a moment. I am resuming this session. There are some technical issues on my side. Yeah. सर वो लाल लाल हो रहा है वो देखो ना So hi everyone, I think the issue is resolved now, right? So can you just confirm once is if my screen is visible or not? Right, great. So where were we? We were seeing how to write functions, and lastly we were seeing key what are these comments in C, right? Right. So what happens when you write a C program? You get a text file, hello world.c, which is basically stored on the disk. Now what you can do, so let me just write this my basic hello world program, right? So these are all details. Now let's start with an actual program. So I'm declaring the main function here. The return time to this main function is int, right? So int, my function name is main. This is the standard function. And inside the function, I'm not using any argument. So I'm just creating this blank opening and closing square brackets. And for the function body, I'm using these curly braces, right? And since this function expects some return value, I'm returning one. We will see why we are using this syntax specifically, but for now, just assume that just remember that you have to your any C program should look like this, and it should have a main function, and the main function should look like this. And inside this main function, I can do something, right? So let's say I want to print hello world. So what I will do, I will use printf function, right? Inside the printf function, I can use double quotes printed on the std out screen, right? And here I can just print any string. So I want to print hello world, right? And with exclamation mark, right? Now what you have done, you have written your first C program. Fine. This is your first C program that you have written. Now what you can do, you can simply save your profile and the text editor. And then you have to use your C compiler. So there are various C compilers present, such as clang or GCC. So let's for me, I'm right now using GCC. This is the standard C compiler. GCC, this is the standard C compiler, and you should be using this C compiler so that the standard C notions are present whenever you are writing C programs, right? So the syntax, the way to run compile a C program is type your compiler, so GCC, then your file name. So file name is hello world.c, right? Hello underscore world.c. And then you have to specify your output file, right? So you can say hyphen o, which says what will be the output file. The output binary should be a.out. Let's call it hello world, hello underscore world dot out. So you have to create a dot out file. That is the output compile function created, compiled executable that will be created after compiling this C program. So someone is asking, can we use any compilers? You can use any C compiler. So the standard compilers are GCC and GCC, and you can also use Clang, which is a bit advanced, but I do not recommend it right now. So you should be using GCC for now. If you are using on Linux or Unix machines, if you are using Windows machines, you can use MinGW compilers, right? So yeah, so this is the way. This is the way how you will be compiling your program. When you run this statement, you if you get no errors, so this means that your program has been successfully compiled. And when you look into this directory, so I am since I'm on a Unix terminal, I can use the Unix command ls here. So I can type ls here. And when you type ls, it will simply list all the files present in the current directory, current working directory. So when you click on it, you will see there are two files created here. One is hello world.c. This was our source C file that contains the C program source code. And we have compiled our hello world.c file and asked the compiler to write the output in the hello world.out executable. So you can see hello world.out has been created here, right? So I can do one thing. I can remove this hello world.out to show you that actually the compiler is actually working. So right now, if there is no, if you haven't compiled your program, you can see in the current directory, there is only one file, hello world.c, which contains our source code. Now again, I am running my compiler compilation step. So I use GCC, then my file name, hello underscore world.c. And then I'm saying the output should, executable's name should be a.out. So hyphen o space a.out. And you run this program command. And then you see an ULS in this current file, you will see it creates the file a.out here. right? Now, how to run this compiled executable in in Linux terminal or in Unix terminal? What you can use this. You can run this like this. So simply you have to run this executable. The way to run any executable is just type dot front slash a dot out, the executable name, and you will see the program is printing hello world here. Everyone, can you find this? Is this clear, everyone? Now, will you be able to write your simple hello world program in C? Great. So if you have any doubts in writing and understanding C programs, please ask me right now so that every one of you is able to practice these problems in future, right? So this is a very basic C in your terminal, right? Great. Now let's move on back to our problem, right? So my program says, what will the output of the program below? It says hashtag include stdio.h. So basic. So I'm including basic IO library so that I can use functions such as printf, right? Right. So yeah, before proceeding with the problem, there is some doubt here. So the doubt rises from the previous lectures of C. Machine language is dependent on the hardware architecture of a computer, but it is independent of the programming language used, right? Even then, in what sense are high-level programming language described as machine independent? Okay, let me see. Hmm. Architectures of C. Machine language is dependent on the hardware of architecture of a computer. So, yeah, there are multiple stages in running a C program, right? So let's say whenever you write a programs in any programming language, what happens? You need to translate that program in that source code into some machine understanding language, which is the low level binary language, right? So for that, you need some intermediate programs that actually understand both languages. One is your binary language as well as the high level language. For this, for each programming language has its own way of doing this. Some are compiled language, some are interpreted languages, right? So in the compiled languages, what happens? There is a compiler. What it does, it takes all the source code and translates it to the for translates it to the whatever machine understandable language that the machine can understand, right? Now that compiler is essentially is a library that depends upon the machine that you are using, right? So that depends on the operating system that you are using. But the way these programming languages are machine independent is it actually means is you can write a program on any machine and then use the specific compiler for that environment in which that is running on that machine, specific OS that is running on that machine, and that will be able to translate that source code to the machine language that is understandable by that machine. This is what it means. It basically means this: you can write the same C source code in multiple machines, in different machines, and that source code needs to be again translated to the machine language. But the source code is same in all the machines, right? Someone is asking what is the compile code. So compile code is basically a dot out, right? We saw that a file was created a dot with name a dot out that was containing the executable, right? That contained the compiled information. So someone is asking why can I use dev C instead or whatever, right? So basically the aim of this course is to help you understand how to start with programming in C and how to write C programs, how to use C for solving your problems. So let's not deviate from that track, right? Fine. So now let's go back to our problem. The problem says we have a main function here has that inside the C program I'm including the standard IO header library, right? And then I am declaring my main function int main, and inside the main block I am declaring a variable a, right? A equals to 9, and then printf and then return 0. So everyone please go through this program first and then let me know the answer, and then I will explain what is the correct answer, right? Right? So let's see the answers. So most of you are answering compilation error. That's correct. Why? Because basically the C programming language is a statically typed language, which essentially means for declaring any variable, you need to declare its define its type, right? So here in this line where I am saying I am assigning the value 9 to the variable a using the assignment operator equals to, I'm not I'm not declaring the data type of cause and compilation error. So this is the limitation of a statically typed language. So C requires you to define declare the data type of each variable before using it, right? So this will cause and compilation error, right? So the correct answer is option D, compilation, right? Right? Is this clear? Anyone do you have any doubts? So in C programming language, if you want to declare any variable, you have to write its data type and then only you can use the variable name. Tools to use a variable's name. For example, you cannot use number as a starting variable name, right? You cannot use the predefined keywords that are present in the C language as a variable name. So these are some rules that you must go through before declaring any variable in C. Any doubt in this program, in this problem, everyone? Please type in the chat box. Great. So let's move on to the next question. Again, what is the output of this program? So here we are, yeah. So here what we are doing, we are This is the including including basic IO header, right? So this header essentially contains the printf statement. So in which function? Yeah, so let me solve this problem and then I will take the doubts. Yeah. So now in this second line, everyone, are you familiar with this statement? Hashtag define. Yeah. So yeah, everyone, are you familiar with this hashtag define statement here? Wasn't this covered in the first week's session, second week's, right? So let me give you a brief review of another C feature, right? So there are some things known as macros in C, right? Macros in C. What are macros? Macros are basically statements that that replace that are used as placeholders, right? So right. So it's a placeholder. So they are basically placeholders that replace the that basically what they do is that represent a value or an expression or a code snippet, right? So what essentially this means is, so for example, I'm not writing a C program here. I'm just giving some example here. For example, I'm saying, so I have a macro m that represents the function, uh, let's say two times the given, just two times, right? Whenever, so for example, m looks like this, m is equals to 2 into, so what this means, m is defined as 2 into, what this means is, wait a second, yeah, this means, and now in my program, let's say I'm saying int a is equals to m4, right? What it does, it replaces m with two times, right? So it replaces m with two times, right? So what is this? This is equivalent to, uh, translates to, right? Translates to 2 into 4, right? So it's a placeholder basically. So you see, whenever you see a macro, you simply replace it with the expression that it represents, right? So here m was representing 2 into, so you simply replace it with This is a very generic explanation to macro, right? And then hashtag define statement is used to declare define. So hashtag define is used to define macros in C, right? So whenever you see hashtag define, essentially what you are going to define a macro in the C program, right? So now what I'm defining a macro fun, and we can always define macros with input arguments in C. For example, this macro takes input X, and what it does, it replaces this placeholder fun X, right, in the C program with this statement, which is X multiplied by X inside the smaller brackets, right? So so this is what we have done. We have declared a macro here, which takes an input X and replaces it with X into X in small brackets, right? So now let's look at our program here. Right. So what is the output of this program? Okay. So we have a macro fun X. So wherever we see fun in our program, we'll replace it with the macro expression. So it becomes so in this program, so first line is I am starting my main function, right? In the main block, I have declared a variable I that belongs to data type float. Float is used to store fractional numbers, right? For example, 1.4, right? Now, yeah, now I am assigning the value I is equals to 64 divided by fun of 2, right? So now you have to replace this. So fun of 2 is simply a placeholder, right? So fun of 2 is replaced with 2 multiplied by 2, right? You can see the placeholder was defined as fun of 2 and it has to replace it with 2 into 2, right? Right. So this becomes I is equals to 64.0 divided by 2 into, right? And that 2 in a small bracket, right? So what is the value of I here? So I becomes 64 by 4, which is 16, right? So now I stores the value 16. Now what I'm doing, I'm using printf statement, and we all know the syntax for printf statement, which is a string, formatted string, which is this is basically a formatted string. We call this formatted string. And how to print, so whatever is present in the string will be printed on the std out. So basically your terminal screen. And what is this percentage dot 2f? So these are format specifiers for a formatted string in C, right? So these are so percentage is used to declare format specifiers and formatted strings in C, right? So percentage D is for saying that printing integer value, right? Similarly, percentage F is for floating point values, right? Now, in this format specifier, you can see it says dot to F. What does this mean? This means print floating point values up to 2 decimal digits, right? Up to 2 digits after the decimal, right? So, for example, if I contain the value 2.34, something like this, so what it would print? It would print 1.23. Take only two digits after the decimal, right? So what it will print on the screen, it will print I stores the value 16, and you have to print floating value up to two decimal digits after a decimal. What you will print, it will print 16.00, right? And then you exit the main function by returning 0, and yeah, you are done. So what is the correct answer? Option D, right? So yeah. So this is how this program works. So basically in this program, what we learned about these macros, water C macros. So these are basically placeholder functions, right? You can use these placeholder functions, right? And then this is your main function. In the main function, you are declaring a float value, float I, right? And then you are writing an expression I is equals to 64, which is a floating point value, 64.0, divided by, so divide front slash represents the division operator, and then fun of 2. So basically you are calling a placeholder with value 2. So this macro fun is replaces this 2 with this block, which is 2 multiplied by 2 inside a small bracket. And then your expression becomes I is equals to 64 by 2 into 2, which is 64 by 4, which is 16 in decimal values, right? And then you print the value using format a printf statement, and you are using the format specifier percentage dot 2f, which prints floating point values up to 2 digits after the decimal. Is this clear, or are these concepts clear? Are you familiar with these concepts? Do you have any doubts? Right? Great. So someone is asking from where should we get the older lectures? So I think everything is present in the NPTEL page. You should be able to use it, right? Yeah, someone is asking what is double precision and float. What is the difference between float and double? So float uses essentially 7 bits for storing precision bits, and double uses 14 bits. You will be looking into these representations in future, right? So these are the standard that we are using is IEEE 754, and you will be seeing that these are the bits that are used to store the values after the decimal point, right? Any doubts in this program, in this problem? I think second line is this program, right? So the second line essentially says, Acha, so this macro, right? You're asking about the macro. So essentially, there's a difference between bits and precision points, right? So bits, precision values, basically it means that it can store up to 7 decimal points without loss of precision. That's it. And someone is asking what does line 2 say here? So line 2 is essentially uh, your is a macro, which is a um, this is a basically it is basically a what we it's a placeholder for for replacing the section in your program, right? Yeah, macro is declared before the main function. Yes, just below the headers, you can define your macros. Right? Machine freeze. Just a minute, guys. My machine is frozen. Okay. Yeah. So yeah, let's me. So I'm back. Yeah. Let's start. So yeah, someone is asking what is the difference instance. So basically, macros are preprocessor directives that are declared before the program execution begins, and constants are variables defined in the memory of the program. Yeah, so that's the difference between them two. We will be showing them in future, but right now, let's not get deviated from the topic too much. Right? So yeah, any other doubt in this program, or should we move to the next problem? So yeah, you can use hash define for the so that's the difference between constant variables and this macros, right? So okay, so let me explain what a macro means actually. Let me actually show you how can you use it. Right. So right. So let me create a new file, macros.c, right? All right. So first I will include hashtag include my standard IO stream, right? IO stdio library, right? And then my main function. And inside the main function, I use return zero. So this is the basic C syntax for any C program that we'll be using for this course, right? So now these are preprocessor directives. So hashtag include stdio.h, just tell this include all the headers present in this file, which is stdio.h. This is provided with bundled with the C programming language compilers itself in the C programming language itself, right? Now I can define my macros using the hashtag define with keyword, right? You use hashtag define and then write your macro. So any macro here. And what this macro is, it is essentially a placeholder for anything inside the program. Now let's say I am defining my macro that stored the value 10, right? Now what it means is inside my program, I can use this macro anywhere, right? So I can say int2 equals int x. So I'm declaring variable x is equals to any macro, right? Any macro multiplied by 4. And then I can say what is the value of this macro. So printf, then in the string x is equals to percentage %d is the format specifier, right? And then I can print my value x here, right? And I can optionally change line here also, right? Every right. So now what this any macro will do, it will basically replace this segment. So this is equivalent to writing int x equals to 10 into 4, right? So wherever you observe this macro, whenever this macro is present in the program, that location will be replaced by this value that this macro represents, right? Right. So let's try to compile my program here. So I will use in my terminal, I can see I have this file macros.c. So let's compile it gcc macros.c -o. The output should be a.out, right? Now you see in this directory, I have created a file named a.out. Now I can execute my file .run/a.out. And you can see it is printing x equals to 40. Everyone, can you observe this value? Fine. So what this program did is basically what it's doing is it is basically this. What is this macro? What is this hashtag define? This is defining a macro. The macro name is any macro. It is a placeholder for anything that comes after the macro, and the value that comes after the macro is 10. So whenever you write x equals to any macro into 4, it essentially replaces that position with the value 4, right? It's just a placeholder, right? Now the macro can also optionally take some arguments and then replace some values, right? So 10, let's say I am writing this kind of macro, right? So what this macro does is it takes some argument, right? It takes an argument and replaces that, it is a placeholder, so it replaces that location with the value that it represents. So my placeholder is in a macro and the variable x inside it, an argument x inside it. And what it does, it replaces that position with 10 times x and these brackets, right? So now what it does, This essentially is equivalent to saying int x equals to 10. So this is equivalent to saying 10 into 1, right, into 4. This is what this macro does, right? So let's simply do this, use this again. Let's compile my program, gcc macros.c, and then run my a.out file. So you can see it's again printing 40 here, right? Is this clear, everyone? Are macros clear? So they are basically placeholders. That's it. Great. So let's move on to the next problem. So the following C program swaps. I don't think. No, I'm not going to solve this problem. Right. Right. So is this clear, everyone? So now let's say someone is asking how to use it, right? So let's see how to use it. Um, so let's see a real-time usage of in real life. What is the use of these macros? So right. So let's say I am trying to write a program that let's say I'm trying to write a program that basically returns prints the square of a number, right? No, let's write a program to print the table of 2, right? Yeah. So let's say table of 2 dot c, right? So I've created this C file, right? First, I hashtag include IO stream. Oh, sorry, stdio.h header file, and then I declare my main function, right? Inside the main function, I return the value 0 to successfully say that program has existed, right? So this is this is my basic C program, right? Now write a program to print the table of 2, right? How to write this? How to write this kind of program? How to do this, right? Up to 10, let's say, right? So what I will do, I will start printing the values. So use the printf statement, printf, right? And then I will pass the formatted string into this. So I will say 2 times 1 is equals to, and let's say I'm using %d to print the value. So 2 into 1 here. Let's see if it works. Right? So this is my basic syntax for printing the table of 2 backslash, right? Right. Now, let me write this for the entire statement, right? 2 times 2 equals %d backslash n, comma, 2 into 2, right? Let me duplicate this up to 10 times. 2 times 2, 2 times 3, 2 times 4, 2 times 5, 2 times 6, 7, 2 times 8, 2 times 9, 2 times 10, right? So now what it will do, it will print my table of 2 times 3, 2 times 4, 2 times 5, 2 times 6, 2 times 7. 8 2 times 9, 2 times 10. Right? Now what I can do, I can compile, so again, compile my program. So GCC table of 2.c and then run my a dot file. And you can see it's printing the table of 2. 2 times 1 equals to 2. 2 times 2 equals to 4. 2 times 3 is 6. 2 times 4 is 8. 2 times 5 is 10. 2 times 6 is 12 and so on, right? Everyone, is this clear? You can see that how I am using C to write my table of 2, right? Now, my goal is, what I want to achieve is, I can observe in this program, I am doing some mathematical operation inside the printf statements, which are repetitive, specifically this 2 times block, right? You can see 2 multiplied by is occurring 10 times in the program, right? So first of all, is this program clear, everyone? I'm just showing you how you can use macros to clean up your program, right? That's it. How you can use it as a placeholder. So is this clear? So first of all, just see this C program. Is this C program clear? Do you have any doubts in this? This program is essentially printing the table of 2 up to 10, right? Now I am showing you in this program, you can find a pattern here that you are using this statement 2 into. So you can see the statement highlighted in yellow. You can see 2 multiplied by is written 10 times in all the 10 printf statements, right? So what I can do is I can replace this with some placeholder, right? So I want to define a placeholder holder for 2 into, right? Can we do this? Right? Let's say if we define, then we can simply use placeholders in on these still lines. And yes, we know we can use macros here. So we can use hashtag define. And then I can time 2 times. So the name of my macro is 2 times. And what it represents is it represents 2 multiplied by. That's it. So this is my macro now, right? And now what I will do, I will simply replace this with 2 underscore times here. Right. So it takes an argument, right? It takes an argument and it returns 2 into that argument, right? Right. So now what I have done is I have replaced my entire 2 times pipeline, right? Instead of writing 2 times 2, you can simply call this use this placeholder that takes in an argument and replaces that line with the value 2 into that value, right? So again, let me replace this 2 underscore times 3, right? Right. So I can simply write 4 here and then 5 and then 6, right? And then 7 here, 8, 9, and 10, right? So now what I have done, instead of writing 2 multiplied by something 10 times, what I have done, I have declared a placeholder 2 times that takes an argument and replaces it with twice that value, right? And now you can see again, I can compile this program and see the same output. So it prints the table of 2. Is this clear? So it's a very basic explanation example of how to write C programs, right? And I've shown a program that uses a macro to print the table of 2, right? You can also use it to define some constant values. So let's say I'm define pi as 3.1415, right? and you can use pi. You can write a program to write up area, right? So float area of circle is equals to pi into radius. So let's say 2 is the radius, right? So you can also use these macros to declare values, constant values, right? So yeah, you can use loops for this program, but since loops are not covered yet, so I'm not going to loops for this program. So now is this clear? Basics of macros, how to use macros in C programs. Will you be able to write basic C problems to solve basic math problems? Right? Right. So now let's take up a problem to introduce if-else statements in C, right? So these are basically logic checking functions, right? Right. So let's start. So write a C program to check whether an integer given as input is even or odd, right? So how to check if the integer given as input is even or odd, right? So let's see. Right. So let's create a new file. Again, as usual, as we saw in previous programs also, I need to use the include stdio.h for basic input output, and I declare my main function. And in the main function, I return 0 here, and then I can write my logic, even odd logic here, right? So how to check if a number is even or odd, right? If the function is divisible by 2, it is even. If the sorry divisible is the if the number is divisible by 2, then it is even, else it is odd, right? Right. So in C, we have the modulo operator. Modulo operator. What it does, it returns the result of remainder when the operands are results of remainder, right? So it works on binary operands, right? So let's say if you have it looks like this: operand 1 modulo of operand 2. What it does, it returns the remainder of division operator 1 by operator 2, right? For example, I'm saying what will the output of 10 modulo 3? What is the answer? Anyone? So what you do, you divide 10 by 3, and what is the remainder that you observe is returned by this function. So what will be the remainder here? 1, right? Similarly, 10 modulo 2 will be 0. Then 10 modulo 4 will be, anyone? 10 modulo 4? 2, right? So this is how your modulo operator works. So whenever you need to check in your program logic, you want to check if a number, if what is the remainder of a of the given division operation, you can use modulo operator, right? And why we need it here? We are trying to find if a number is even or odd, right? So let's declare a number. Int number is equals to, let's say I have number 10. So now I need to develop some logic to check if the value stored in variable num is even, right? So what this means? It means num modulo 10 should be equals to 0, then it is even. Sorry, num modulo 2, sorry. here num modulo 2, then it is even, else it is odd. So for this, we have if, basically we have if and else statements in C. What it means, if the syntax looks like this, so you have a if statement and some condition here. So if, wait a minute, guys. Yeah. So sorry guys. Yeah, there was some network interruption here. Yeah. So basically, so this is the syntax, right? So if some condition, right? The the condition can be store a Boolean value, which can be true or false, right? So so and the if block says that execute these statements if the condition is true, right? And then if it's not, if the condition is false, these statements get ignored. Optionally, you can have an else statement here, and then these statements can be execute these statements if the condition is false, right? So, and it is totally optional, right? Totally optional. You need not, you do not require, you are not required to have else statement for all if statements, right? You can always have only if statements too, right? So now in our program, we want to check if the number is divisible by 2. So you want to check the value of modulo 2. It should be equals to 0. Now in C language, you have two types of equal to operators. One is assignment operator, one is comparator operators. For comparison, you use double equals to, and it checks if the values on the left hand side is exactly equal to the value on the right hand side. So if num modulo 2 double equals to 0, then your number is what even number. So you can print tell the user that the number percentage d is even, right? And then you can print num here. Again, if this is not the case, then you can simply print the number percentage d is odd, right? Now you can run this program. So gcc even odd.c and then run your program. It will tell that the number 10 is even, right? Now, if I change my number to 11, you will see our program will be able to. So number 11 is odd, right? So this is how you can develop actual real maps, logic, and solve problems using programming in C. So in through this program, what we understood is how to write a basic, how to use the modulo operator, what it does, and then how to use conditionals, what are Boolean values, right, which are essentially true or false. And then we saw this comparator operator, which is double equals to, and we saw how to use if-else statements in C, right? Anyone, do you have any doubts in this program? Fine. So now if you have any doubts, so in this session, what we saw is we saw some basic programs on solving problems in C, right? How to solve basic math problems using C. I can take up another problem here, right? So let's take, right? So let's solve this problem. Write a C program that takes an year as input and checks if it is a leap year or not, right? Again, leap. So we want to, let me just define the problem first. So the problem is style include stdio.h, right? Mean return 0, right? So write a C program to check if the given year is leap or right. So let's declare an integer variable int year, and let's say it's the current year 2026. We want to check if it is a leap year or not. So let's see how to do this, right? So can anyone tell me what logic should I use here? Right? Right. Someone is saying number modulo 4 and someone is saying number modulo 400. So let's see how to check this. So first again, the logic is we all know that if the number is well by 4, it is a leap year, right? It's a very ungeneric rule, right? It's not exactly correct, but let's go with this logic first, right? So again, what we use if statement and we use the condition. The condition is if year modulo 4 is equals exactly equal to 0. So if division of year with 4 returns 0 remainder, then simply print f the year percentage d is a leap year, right? And you can simply pass the value of this year as year here, right? Else you can print the is the year is not a leap year, right? So this is the logic that we are using to check if the year is a leap year or not. Now what we can do, we can compile our program and then check the output. You can see it says the year 2026 is not a leap year. And we know this because we know the calendar for current year. 2026 is not a leap year because 29 days, right? Now let's check if the year 1900 was a leap year or not, right? It says the year 1900 was, sorry, it's not is, it is was a leap year, right? Again, you can see it says the year 900 was a leap year, right? So anyone, can you tell me if the year is leap year or not? 900 was a leap year or not? Was 900 a leap year? No, right? You can check on the internet. 1900, the year 1900 was not a leap year, and 900 was also not a leap year. So what is wrong here? The logic is wrong. So this is only true. So the above logic is only true if the year is not a century year, right? So if it's a century year, if the year is a century year, we need the logic. The year should be, it must be divisible by 400 to be a leap year. And that you can check yourself. It's a simple math problem. So let's say if the year started from 1 and every fourth year is a leap year, then what happens to the years, century years? So what happens to the year which are multiples of 100? So what happens to the year 500? What happens to the year 600? What happens to the year 900? What happens to the year 300? Will they be the leap year or not? Right? So you can formulate the math. But I am just telling you that you have to check if it's a century year, that it must be divisible by 400. So now first you check if the year is multiple divisible by 4, then it can be leap year. And then now what we are going to use is something known as nested if else statement, right? So right now you can see it's a plain if else statement where if some condition do print something else, print something else, right? Now, what are nested if-else statements? So you can always write if-else statement inside the if-else block itself, right? So within this block, you can write another if-else statement, right? So let's write another nested if-else. If year is a century year, that means if year modulo 100 equals to 0, right? Then you again have to check if year modulo 400 equals to 0, right? So then only the year will be a leap year, right? Else the year was not a leap year, right? And if it's not a century year, then it is already a leap year, right? So I used nested if else statements to check if the year is a leap year or not, right? Now, in this check, you are seeing, right? Let me just, oh, sorry. Yeah. So this is our complete logic. So first we check if a year is divisible by 4. If it's not divisible by 4, definitely it's not a leap year. If it is, then you have to check if it's a century year. That is, if it is divisible by 100. If it is divisible by 100, you have to check that year should be divisible by 400. If it's not, then it's not a leap year. Now coming out, if the year was not a leap year, a century year, then and it was, we already checked if it's divisible by 4, then it is a leap year. Else it is not a leap year, right? So let's check. So it says year 1900 was not a leap year, right? Meanwhile, if you are checking for the year 2000, then you will see that it will be a leap year. It was a leap year, right? 2000 was a leap year, right? So this is how this program works. So through this problem, what we saw, how we use if-else statements, right? How we use nested if-else statements and solve our problem, right? Is this clear, everyone? Do you have any doubts in this C program? Yeah, so those who have doubts, can you just type in your doubts here? Yeah. So what is a nested loop? Basically, it's not a nested loop, right? It's a nested if-else statement. So it means inside an if block, I can have another if statement here. For example, within this if block, right? This is an if block. Inside this if block, I have another if statement here, right? So this is another if-else statement inside the if statement. So this is what nesting means, right? So I will explain loops later on when we go to loops, but now we are only interested in the if else statements. So yeah, it's very standard. Like if you can write if else statement inside an if else if block, that's it. That's what only that is what it means to have nested if else statements, right? Is this clear, everyone? Right. So you can see I'm saying if this condition is true, then you execute this block, right? Now, when you go inside this block, you have another condition. If this another condition is true, then execute this sub block, right? Else execute this sub block, right? Now, in this sub block also, there is another condition, which is checking if it's true, else not, right? Right. So that's all for today's session, everyone. If you have any doubts, please type in the chat box, or otherwise we can end the session also. Someone is asking how to access these recorded sessions. So the recorded sessions are listed on the course page itself. And if you're not able to find there also, you can email the NPTEL team, right? If no one has any doubts, then can we end the session? Fine. It's fine. Thank you all.